Alright, topic number 18. I tell my students, do not overthink this, at least at our level. There are higher levels where you do a little bit more with this, but for us, it's really just statements of type 1 and type 2 errors. So basically, type 1 and type 2 errors are basically errors that could occur with the hypothesis test. Now, one of the things I didn't mention in the last video is what we're really using when we go into the statistically significant realm. And what we're looking at is outliers. So outliers can tell us a lot of things. If we have too many outliers, that means the trend is probably trending to change the population parameter, which is what the hypothesis test tests. It tells us whether or not it's still the same as it used. The population parameter is still the same as it used to be. On the other hand, an outlier can also be an error on our parts. We could measure something wrong, something could go wrong. So this is basically the other portion of that. What happens if we were wrong with our hypothesis test? So we get what's called a type 1 or type 2 error. So we're going to look at what type 1 and type 2 errors is. We're going to look at how to apply both errors. And we're then going to talk briefly about probability of a type 1 error, because you can't really find probability of a type 2 error in this case. And then we will go on from there. So this is what we started off with our other topic. We said Giant Foods and Dundalk claims that 93% of their customers approved the way that the store is managed. Not fully believing this, individual decides to run an experiment, decides to poll customers as they leave the Giant. He picks 500 random individuals, discovers that the percentage of satisfied customers is actually 90%. Is this enough evidence to prove that the satisfaction of customers is different from what we stated? Last time we looked at a video, we said we rejected the null hypothesis. There was enough evidence to show that the percentage of satisfied customers was different than shown. So we went through the whole hypothesis, the hypothesis test process, and found that we had this conclusion. So we come up with a hypothetical situation of what if our conclusion is incorrect? Well, we get what's called a type 1 error. And a type 1 error is... A type 1 error is when you reject the null hypothesis, but you shouldn't have rejected it. So, you're basically saying you're able to find a p-value that is less than the alpha level, but you made some error in finding it. Now, usually the error is not in the calculations that you did in the actual test itself, but it's probably sometimes it could be based off a false assumption. There could have been some data collection errors. But this is a purely hypothetical situation. You usually don't know if you have an error until you actually see that you have an error. So this isn't something where you're going to be trying to be like, oh, I have an error, and this is definitely an error. This is like, if I have an error, this is what it would be. So you're not trying to determine whether or not you actually have the error. You're just determining if you have an error, what would it look like. So a type 1 error is basically when you reject the null hypothesis, but you shouldn't have rejected. In the previous situation, what we're going to do is just state the possibility that it could exist, because we'll never know if it definitely does exist until it happens. So for the hypothesis test on the slide 3, we would say that if we have a type 1 error, we said the satisfaction of customers was different when it really wasn't. So if you go back real fast, here we stated that we were able to show that the percentage of satisfied customers was different than showed. The error would be in that. So we would say that we did in fact show this, but we did it incorrectly. We did show that there was enough evidence to show that the percentage of satisfied customers was different than showed, but in reality it was not. So that's all you would say. We also might state some consequences of what happens if we are wrong. I don't usually force that on my students anymore. They're hypothetical situations that people don't like to think about. If a type 1 error is rejecting a null hypothesis when we shouldn't have, what is a type 1? Was a type 2 error? Well, it'd be the complete opposite. It's failing to reject a null hypothesis when you should. in a certain state, the percentage of males born account for 48.5% of the babies born at any given time. This is the second one we went over on the previous video. A sample of 700 babies is taken at random from all the local hospitals, and it's found that 50.1% of the babies are male. Does this give enough evidence to show that the percentage of male babies has risen? Conclusion that we made was that there wasn't enough evidence to prove that the percentage of male babies has risen. If this conclusion is incorrect, and we don't know if it is or not, but we're just saying if it is, we have a type 2 error. So, what do we do with a type 2 error? Basically the same thing as a type 1 error. State the possibility that it exists because you don't know if it definitely does. In the previous problem, we say that the percentage of live we didn't have enough evidence to show that the percentage of live male baby births didn't go up when it actually did. Again, we may state some consequences based off of that, but we don't necessarily have to. So what does this kind of look like as a question altogether? Well, let's take a look at this one. Duracell creates efficient batteries. It claims that only 3% of the batteries come off the line ineffective. A rival company decides to do a study on and buys 1,000. That's just my bad English. And buys 1,000 battery terms at 5% are defective. This is enough information to determine that the amount of Duracell batteries is different than Duracell advertises. So first off, we're going to have to go through the whole entire process of doing the hypothesis test again. So we'll start with step 1, and so step number 1. All my markers are starting to dry out. Means I need to get some more. Step number 1. So we have 1 random. So 1,000 batteries. We're taking it random. I don't think it says in this case, but you can assume that it was. Sometimes I forget to write the word random. 10%. 1,000 times 10 equals 10,000. 10,000 batteries is less than all batteries. Then we have success failure. Excuse me. So let's see. If I go back here, the population proportion is 3%. So we're going to do 0.03 times 1,000, 0.97 times 1,000, which gives me 30, which is almost not good enough, but 970 for the other one. And so it's good. We can go on with our hypothesis test. Step number 2. We have a null, an alternative. We're going to say the proportion should be 0.03. If we go back, the final thing says different. So BP is not equal to 0.03. Step number 3. So it's 1 minus 0.03 times 0.03 over 1,000. So 1 minus 0.03 times 0.03 divided by 1,000. And you take the square root of that. Point 0.0054 and 0.05 minus 0.03 divided by 0.0054, because remember 5% is the other percentage on there. Got 3.70. Okay. Now, I need to go look up my z-square chart, and I just realized that I've minimized it, so let's reopen it up. And here's kind of the problem. It only goes up to 3.9. So when it happens, I usually just tell my students just to go ahead and take the very last one on the chart. So it's 0.9998. And then remember our rule from last video. We said that if when I multiply this, because it's not equal to, so we're going to have to multiply it by 2. If when this is greater than, if I'm going to multiply this by 2 and it would be greater than 1, we first have to subtract it from 1. It should be 0.0002, and then we multiply it by 2, which gives me 0.004. Okay? Now, there's no alpha level stated. Whenever there is no alpha level stated, it's just 0.05. So, step number 4, we're going to say 0.004 is definitely less than 0.05, so we reject the null hypothesis. We do not, or we do have enough evidence to prove that the, let's see, we're talking about the percentage of defective batteries, the percentage of defective batteries is different than stated. Okay, so we got that. Now, question number 2 says, well, what type of error do we have? Well, it's all based on our conclusion in this one here. Since I rejected the null hypothesis, then it has to be a type 1 error. So question number 2, it has to be a type 1 error. Can't be a type 2. Type 1 error is based off of rejecting a null hypothesis. Type 2 is not basing off not rejecting a hypothesis, failing to reject a null hypothesis. So it's type 1 error. Finally, what does it mean in words? Well, not 4, 3. So how do I write my type 1 error in words? Well, we said, so basically I'm going to just rewrite this for the first part. We said that we had enough evidence to prove that the percentage of defective batteries is different than stated, and then I'm going to put when it actually wasn't. So just basically saying it's just not true. Made an oopsie. We didn't do it correctly. Okay. And that's pretty much it. That's all you have to write. Okay. And I don't really do 4 anymore, again, because people have a hard time coming up with stuff. There can only be 1. Why can't there be more? Both. Why could the ha ha ha? Why can there not be more than one? Why? I can't say it. Why can there not be both a type 1 and a type 2 error? And the reason is because you cannot have both. You can. Wow, I can't say that word both today. Because you cannot both reject and fail to reject the null hypothesis. So, you can only have 1, just like the Highlander. There can only be 1. Dated reference. Okay? And just a quick look at probabilities. Probability of type 1 is equal to the alpha level. So in our previous example, we had a 5% chance of having a type 1 error. Probability of type 2 we can't calculate in this class. You can do it in higher level classes because it's called beta, and then you have to do some fun little things. Thing you should note though is that the errors are inverses of each other. So if you lower the probability of one, you will raise the probability of the other. So if I lower my alpha level, I'm actually raising the probability of getting a type 2 error, which makes sense because I'm making it harder to reject the null hypothesis anyway.